Hello, everyone. Today is June 1st, 2020. This is the Kubernetes Data Protection Working Group meeting. So today we have a main topic, which is about CPT. So Fawn and others who have been working on the CPT project will be giving an update. So with that, I will give that to you. Fawn, let me stop sharing. I think you should be able to share.
Yeah, thank you. Let me try to share my screen. So can you see my screen now?
Yes.
Yep. Okay. So this is like a community project that we've been working on it for a while, and recently Ivan, me, and Prasad, and now a few more. Sean also worked actively on this. So we presented to the community sync up in last week, and we got some feedback. Today I will share with you all the feedback and all the current status of it. But I also want to walk through a little bit so everybody who did not attend that meeting would have some background of what's going on. For this, we propose a cap for different source snapshot cap. I put a link on our meeting document here. We have a link here, and so this is the document, the cap that we are proposing. And this cap have two main parts. One of them is the enhancement to CSI interface that we want to introduce, and that one is over here. So this one is the different source snapshot service that the enhancement to the CSI that if a vendor who want to support this CSI enhancement, they can implement this service here, and they can add this into their CSI driver package, and it will go to support this. So this one, the feedback on this one, we don't receive any negative feedback on this CSI enhancement. So the other part, which is the enhancement to, I mean the CRD, which is how we use this, for how the user would use this differential snapshot CSI, is have received some feedback, and we need to address those feedback. I think there's some critical feedback from, I think, from Ben, and then another one from Seth, that ask us to reconsider many, a main component in our path. So let me walk through the design quickly first, and then I will introduce what Ben and Seth has feedback to us, and then Ivan will help me share what we have done to address this. So by the way, this is I also put the link that Ivan is proposing to addressing feedback from Ben here. So later, if I run out of time, he can you guys can just look into the document and know what's going on. So let's quickly walk through the proposal that we propose for this one first. So when the user want to get the differential snapshot between two pre-existing snapshot, let's just say the user, like a backup client, right, like backup vendor, create a volume snapshot 1 of the PVC, and then later he create a volume snapshot 2 of the PVC during his backup procedure. And now he wants to make a differential snapshot of this. So what he can do is he can create a get chain block CR in the same namespace with the volume snapshot. We would then have our CSI snapshot sidecar, the blue box that you guys see here. This will watch for this CR, and when it see that he created, what it does is it will make a gRPC call to the corresponding driver. In this case, in this example, we here is the EBS, the Amazon EBS. We put it in our demo to as an example of how this one will be called. So the CSI snapshot controller here will make a gRPC call to the EBS plugin, and EBS plugin corresponding will talk to the EBS to make the shipment. So snapshot internally is using the lead chain block, but for this, from this architecture, the whole thing from here, from this EBS plugin should be implementing by the CSI, the storage vendor, right? This part, the CSI snapshot, is implementing by the community, and this software part is the backup software is a backup vendor, right? So after the gRPC respond to this differential snapshot, the CSI controller will get the result, which is the whole list of chain block, and it will stuff it into this get chain block CR. So this is the critical point here, because in this design, all of the result, it can be huge. We will stuff into this CR, and then the backup vendor, the backup software client here, will get this chain block list from this CR and proceed with their differential snapshot. And that is the critical point, because we put everything in this CR object, and it can be large. And we have some design to try to mitigate the amount of data that is being stored on the on this object, but it still have negative impact on the I/O of the SCD, and that is what I think Ben and Sat is concerned, is that their main point is that the SCD is not designed for high I/O and for I/O, a lot of I/O here, and we can see that each of the chain block can, I mean, each of these CR can contain a lot of chain block, and it will create some I/O pressure on this SCD, and that is the negative point that we got from this CR. And I think Ben have make some suggestion into the alternative design. I have captured it here in this document about the alternative design that we got from the meeting with the community last week. And after that, we sit back together, we sit down together, and we look into what we can do to address this one, and we need to have some discuss. And after that, Ivan have proposing a new design. Remember that the design that we propose, it do not change the CSI enhancement that we propose. It does not change this part right here. It's only change the first part, which is the how we use this this differential snapshot in the Kubernetes. So with that, I want to pass to Ivan for to talk about the new design, the enhancement design that we're proposing. Ivan, you want to share your screen?
Yeah, sure. I can.
Okay, so I'm gonna unshare now, so you can talk about the new one.
Cool. Let's see if I can share my screen. Can you all see my web browser?
Yeah.
So, sorry, someone wants to say something?
So I can see it. Go ahead.
Okay, cool. Oh, sorry. My voice might sound a bit different today. I'm like a bit under the weather, but I assume I assure you that I'm Ivan. I'm not some like random stranger. Yeah, so like following like the feedback we got from during the CSI community meeting, like we got together and tried to address some of the concerns. And the first thing that we talk about is let's come up with a proper name for, you know, like the API and this CRD and stuff. So what you're seeing here is like the proposed like rename CRD. Originally, like it used to be something called like get change blocks, and then you get change boxes and get change blocks list type of thing. So decided to get rid of that get prefix and call it differential snapshot. Full disclosure, like a lot of these is inspired by like the existing PVC and design and that relationship between PVC and the volume snapshot design. So we borrow quite a bit of inspiration from it. If anything you see here that totally makes no sense, or it's like, oh, don't go there type of thing, just feel free to voice it up, and we truly appreciate those kind of feedback, because you know, that's how we know like we can move one step closer to the targeting goalpost. So yeah, we want to rename like the high level get change blocks CRD to something called differential snapshot. And then there's the spec and the status, not surprisingly. And within the spec, instead of using string for the snapshot base and snapshot target, we want to try something called type local object reference. Again, for those of us who are familiar with the PVC like data source, you know that like the type local object reference is actually a reference to the GVK of like the PVC, the volume snapshot, and potentially any other like third party CRD that the controller may have RBAC permissions to access. So we find this like more generic and more like, I guess, in a way idiomatic. So, you know, in this case, user will specify like you know, the GVK and the name of the volume snapshot for the base and the target as parameters to be passed
Ivan,
to the differential snapshot.
sorry, so do we expect this one to be used for other types other than snapshot though?
So the interesting thing, yeah, so this is the, you know, trying to totally avoid like the, you know, you're trying to like, yeah, like, you know, as you know, we go through like the original requirements and in the white paper and all those things, like, there's a potential that we may have to do differential snapshot for files, even though right now it's block. But so we have some discussion around like, okay,
right, but then in that case, the snapshot based snapshot target, that's still snapshot, right? It's file. You're thinking that may not be a snapshot anymore.
Yeah, so at this point we don't know, right? Like it's whether like so this is the kind of feedback that we are hoping to get. Is using like local object reference like over generalized solution.
Yeah,
or like
it's kind of at this point, yeah, because it's we're doing alpha, right? So making it over complicated, since your this structure name is a differential snapshot anyway.
Yeah, honestly, I don't think it's over complicated, because like at least like I feel like because PVC is using it, I feel like at least it's something that
right. But the reason it uses it was because when we introduced that, we know that snapshot was introduced first. We know that it will be a PVC next, right? And then we also extended that to this, any
right. So
but this one, this is, I think it's just.
Yeah, I also think this should be simply a string of the volume snapshot name should be enough.
So is there not? I feel like so at this point I'm not convinced, but we can take this offline. But is there is there not a lesson to be learned from PVC? You know, like why do we?
No, that's not a lesson. That's because we know at that time there will be other use case coming. We already know that when we added this typed local object reference, it's different from this one. This is different, right? This one we don't really know what else we can use. Potentially file, but file should also be a snapshot. So that's why this is very strange.
Is file going to be a volume snapshot? CR as well?
The difference one.
Yeah, it's
the
also a
difference one.
snapshot. Yeah, file is also, we also use this. We don't have another snapshot API for just a file. It's based on the underlying implementation, right? So it's very strange that you have this one here, that we don't
Okay.
really have any other use case. And then just remember, this is since this is a still alpha, right? So if we want to change this, we can still change later. But I think it is definitely normally when you have this one, we already know something else is coming, like but right now we do not. We don't really have a case coming, so it's very strange to have this here.
Okay, yeah, point taken. So let's let's maybe like if we okay, point taken. Cool.
Yeah, you can make a note of that, and we can change that back to a string later.
Yeah. So and then again, like following the PVC like design, like the moat is where we kind of think like, okay, is it gonna be like a block versus like a file snapshot type of thing? And then just going down to things like maximum entries and custom parameters that can be included in the request. And the status itself, like as Fang pointed out earlier, we used to have like a list of change blocks with the metadata of the change blocks included and embedded inside the status. So for now, like this design is returning a URI, a URL, and then like with the different faces indicating like, because like partially like as things are happening, you can imagine or try to recall like when a pod is spinning up, like under the status, there's different conditions and phases as the pod goes through. So we are thinking like some sort of lists of faces to indicate like what is happening as the as the backup software try to invoke the stream URI to get back the streams of this change blocks.
Ivan, I think for this struct, for this status struct, we might want to add something like an error or status string. Like, so in case that it is a failure, then we can put the error there instead of this this thing here. So we need to add field, maybe one or two more field indicating the status and the error message or description or something like that, that be more information about this is where success or it failed or it warning and so on and so forth,
Right. So actually the faces pattern was not preferred when we were introducing the snapshot API. That's why we have this specific thing, in the status field, we have this arrow, we have, whether it's very explicit, not faces.
Okay. Are there
but I think that, you can change this one later, I think.
Yeah, I haven't like, we haven't thought too much about what okay. That again, totally fine. Yep. Let me just add a note here.
Yeah, this is still in progress.
Yep, that's fine. Final status. Any error? Okay, cool. So that's kind of like what we have in mind. I think the main thing here is really still like the URI. We're gonna go and talk a little bit about our current thought on what the URL should look like. The main thing is to like URI is being embedded into the status instead of a list of like change blocks on metadata. So any other thoughts, comments, feedback so far?
When we talk about the security of this URI, we might want to add some more field into this this different source status. We can talk about that when we get to that point.
Yeah. Okay. Sounds good. So I think So like this is kind of what we envision, like the whole like workflow will look like. So the backup software would create like a CR of differential snapshot, giving it like this to like I guess like at this point like volume snapshot IDs. And then the differential snapshot controller would be watching, it will be a sidecar embedded into the provider CSI driver. In this case, we used the EBS CSI driver as part of our previous prototype. So the controller will be watching the the creations of the differential snapshot resource. And when that happens, like all the controller is going to do within the same sidecar. At this point we are envisioning like two separate process or Go teams or whatever we call it. The controller will update the status resource with the URI, and then originally we're thinking of like some status to show what phase is going through. Again, if this is something that's not desirable, like we can change it. Also want to know and learn more a little bit about why phases are not desirable. So the URI would look something like port number. I think so the stream. Okay, so let's talk about this. Can you all see? Hopefully it's not too small. The fonts. So the stream URI is something that ideally in the ideal case it would be like the service that front the deployments or whatever, like the DNS name, right? So it'd be like foo.namespace.svc.cluster.local. But not all CSI driver actually comes with a service resource. For example, the EBS CSI driver definitely does not have a service in front of it. So we may have to fall back on the actual pod DNS name, and which can be discovered and constructed via like downward API when the deployment inside declare inside the deployment YAML in discovered and constructed as part of the code. So that's kind of like the current thought. So that's the first important thing about the streaming URI. Just how we built it, where the host name, how it is discovered and constructed. So if there's a better way to provide a more deterministic like stream URI without depending on the pod DNS name, then we welcome the kind of feedback and ideas. I look into how with pod you can give it a static host name. You can with I think since 1.22 you can set the host name as the FQDN, all these things, but they all require as to my understanding is the service resource to sit in front of the pod. Without the service resource, I feel like we're pretty limited in terms of the host name.
What's wrong with using the service? Sorry, maybe I missed something, but it sounds like service is the obvious solution. So what's wrong with it?
So the CSI driver may not come with it unless we want to provide one ourselves.
But
I mean, these are deployments. So if the pod restarts, you can update all these objects, to reflect the new pod DNS name.
Yeah, there's all kinds of requirements to deploy a CSI driver, and so I think just included with the YAML for this sidecar would be an example of what you should do in terms of creating a service. And of course, the service would probably have to be named specific to the storage vendor so that multiple services from different storage vendors could peacefully coexist. But I think you just include a sample for how to set up a service that front ends this thing and expect that anyone who actually includes it with their CSI driver by deploying the sidecar will do the legwork to create the service. It seems like the only repeatable way to get this to work in a Kubernetes cluster. If we can, definitely. I personally would much prefer if there's a service, if we can guarantee there's a service resource in front of it, and then we just use the CS service DNS name. I mean, even depending on what the deployment and operation model looks like, we might even be, if it is deployment through a Helm chart, we might even be able to say include a service that select the labels of the pod, right? And then use Helm to do its Go templating magic
during time install to make sure like our service would always select the part of the driver, for example. So
Yeah, but I mean, how it gets installed is usually a question for the CSI driver author, right? Like, oh, we have a CSI driver, and you can deploy it with a Helm, and you can deploy it a bunch of other ways, and that's sort of for us and our customers to figure out. But at the end of the day, as long as a service gets created, then you'll have something that backup software can talk to get this snapdiff data.
Yep. So sounds like it is acceptable, whether it is in the form of documentation or some other communication mechanism saying that, hey, if you want to use this, make sure you put a service in front of it.
Yeah. I think
Okay.
in the Git repo, you'll have a directory called like deploy that'll just have a bunch of example YAML, and it's always example YAML for CSI driver vendors to copy and customize as they see fit, and just say this is the recommended way to do it.
Yep.
But then if someone has a better idea, they're welcome to go do that, as long as there's a fallback that works for everybody.
Yeah, and definitely like yep, that sounds good to me. Like, because the only other fallback I can think of is like the pod DNS. But still, like if we can avoid having to do this, it would be great. So yeah, anyway, so with
the backup wouldn't work because you have to update all these objects upon pod restarts. But for me, the bigger question is this. So basically, one of the problems we wanted to address was to limit the size of these objects, right?
Mm-hmm.
And that's why you have max entries set to 64 there. And and also, it seems basically instead of actually populating the object with the change blocks itself, you're actually providing a URI.
Yep.
So we can find change blocks elsewhere, right?
That's
basically
correct.
provide a link to it.
That's
so
correct.
basically that stream URI is going to basically have a reference, let's say in this case to, let's say a sequence of 64 blocks, right? At most, right?
Yep. We haven't, at this point, when we create the URI, we haven't get the differential snapshot yet. We haven't executed the differential snapshot yet. So we do that. I think let Ben finish his explanation.
Well, basically, I want to understand like what the stream URI points to. That's my question. Basically.
Yeah, it will point to a differential snapshots listener service that the green box on the chart right there.
Yeah. So once we got the streaming,
it's an object inside that differential snapshot listener.
Yeah. So once we got the streaming URL, this backup software would just call and invoke the URL. It will point it back to, at this point, like the same sidecar, but it's a listener process in there. So this listener would just like go through the same gRPC flow that Fang showed earlier. It would talk to the EBS plugin. So the gRPC client side would be, our listener would be the gRPC client side, and then the EBS provider plugin would be the gRPC server side. So we'll invoke the AWS EBS Direct API that says, given these two snapshots. I
think you have it in your next slide, I think.
Yeah, right. And then given the snapshots, now go and call into AWS EBS Direct and give me back all the change blocks. And then like all of these responses would be streamed directly back to the backup software. And then the backup software would be responsible. And then of course, like as these responses come back, AWS itself would also provide like enough information to paginate the requests. So the backup software will have to make the decisions on whether you want to continue to fetch more blocks, over the same streaming URI and pass in more information like, the next token, the maximum results, etc., etc. And at this point, like we would totally like just leave the differential snapshot custom resource alone, so nothing would ever get saved into SCD, and then once the backup software from there can decide what it wants to do with those responses that that come back from AWS. So it's kind of like the general gist of it. I mean, like there are some details around like as we how do we do the streaming between the backup software and listener. I think like one thing that was brought up was gRPC over HTTP, but it means that potentially we have to put like a gateway in front of it, the gateway process. Depending on the amount of footprint there, we may or may not need to. We may have to look further into it, or do we want to follow like what currently like kubectl logs and exact and port forwarding are doing? They basically do like a protocol upgrade to speedy, and then just continue on like the streaming after the protocol like upgrade, and security, etc. So
Did you think about just a plain old REST API with JSON over HTTP?
yeah, I think like if we can just do it with HTTP as an HTTP streaming, like or just straight up the good old handshake request response type of thing. Okay. Yeah, I mean, like
my personal qualm with gRPC is just that it requires code generators and extra libraries and a bunch of stuff that makes it a hassle to consume from some programming languages, whereas JSON over HTTP is you can write a client for that in 5 lines of Python code, or whatever you want to do. It just makes it a lot easier to interact with. And there's really only one thing we're doing, right? Which is, here's the snapshot name, give me back an array of blocks in some format that's easy to parse. JSON seems reasonable.
Yeah, and if you
what is the maximum size for that HTTP response? That's
so HTTP responses are unlimited size, fortunately, but you can also chunk them or have pagination support as part of the request to say, give me the first 100 and then I'll ask for the second 100 later.
Oh yeah, we do have that max entry there. Yeah.
There's a bunch of different ways to paginate an HTTP REST request, and I don't know. The code is going to be a lot smaller if you just do something simple like JSON over HTTP rather than having to go build a whole gRPC, because gRPC is really designed for like high performance sort of communication where you're doing lots of RPC calls and with presumably very small payloads, right?
So
here you're going to have
in that sense, so sorry, go ahead.
You're going to have fewer calls with huge payloads, right? That's what we expect.
Yeah, if we definitely, if we don't need to have like a bidirectional streaming thing, then totally, I think like I'm just plain on like JSON over HTTP is great. It's like, give the response back to the backup server. If you want more, issue another request. That totally works for me. To your question, like there's no size limit, but like the HTTP client, at least in Go, it has some sort of default timeouts that we may have to make it either configurable or try it out to see like how that may affect us. But yeah, otherwise like
yeah, so it's like the CSI different source snapshot listener can be something like a REST server, right? It's when you fetch thing that you call a get command with that URI stream that right there. Then it just get back a body with all the chain block in the body, right?
Yeah, and I wouldn't worry about anything like a timeout. Like these calls are going to be made in environments with reasonably fast networks, where even if the metadata for the change blocks is 100 megabytes, you're going to move that in milliseconds, right? 100 megabytes is nothing for HTTP to shove through a pipe. So I don't see the problem with just using.
Yeah, that sounds good to me. I mean, another thing that another concern that we still debating is the security concern, right?
Sorry, Fang, can I?
Yeah, you
before
go
we-
ahead and talk about that.
Yeah, so, sorry, before we talk about security, the other thing I want to quickly address, because I know security is like a big thing here. It's probably going to take a lot longer to discuss, but like the other like design like discussion we have been having is like whether we want to keep the listener as part of the sidecar, or should it be separated into a different part or entity or whatever workload we want to call it. But I think like at this point, like unless there's compelling reason, we prefer to put it in the same sidecar, simply because like this will allow it to discover, you know, the provider plugin over local Unix socket.
If you need to call CSI driver, then it should be in the same pod.
Yeah, the reason why I kind of bring up that point is because of the scale, right? So the differential snapshot controller is it only do a very little work, but the differential snapshot listener, the box that you see there, it might need to serve a lot of requests coming back and forth, and it might hold on to the connection longer. So I wonder if we can, you know, scale it in some way. If we separate it into like a service with multiple parts in the back, then we can scale it easier. But maybe in the prototype, maybe we don't need to talk about that. Yeah.
Yeah, I think also like you know, yeah, we can revisit it if there's a need. But I think like even scaling itself is not going to help, because your request is going to be sequentially paginated anyway. It's not like you can make concurrent calls. But at this point, like unless there's a strong no, please don't do that, I think we're gonna go forward with just putting the listener in the same sidecar, maybe as a go routine or something. Yeah, so okay, so Fang, you want to talk about security?
Yeah, so the idea was that we do not want other component able to get into the stream, right? We only want the creator of the CR, the differential snapshot CR, to able to read from this stream URI that we post there. So we need to have some kind of protection, the mechanism to put in. We debate on that yesterday on how to have protecting this UI stream from non-intentional user. This CR itself is readable by many components that might have the same permission, right? But we only want the creator of it to access. So one idea is to, I think yesterday we chat on Slack that we have some kind of a secret or a certificate that being created by the backup vendor, backup software that create the CR, and it put the certificate in a secret or something like that, and it share the secret here in the CR. We can put it into like in the parameter or something like that, right? And then on the server side, on the CSI snapshot listener, it might also have its own certificate. And by exchanging a certificate in the establish of the connection, the backup software, the backup vendor here, the creator of that differential snapshot can securely and secretly connecting to the listener, the service securely. And that is one proposal. I think you, Ivan, you can talk about the other proposal that you have.
I think like so whichever approach that we use, I don't think we should make sure we don't put like secret in plain text into the CR, unless it's like the public cert is fine, but definitely not some sort of secret tokens or whatever. But anyways, the so yeah, like you know, there's security is always such a big and broad thing. But at the minimum, the baseline is that we definitely want the communication between the backup software and the listener, for example, to be encrypted over, and to happen over HTTPS. So, now get into conversations like, okay, how do we propagate the TLS cert? What about renewal of the cert, management of the CR trust, and all those things? I think there one, I guess one or two ways I can think of is like basically it can just be another infrastructure requirements. Hey, if you have cert manager deployed already, make sure you have this secret so that resource created, so our CSI sidecar can pull the public cert and the trust from, and then make sure the backup software also trusts the same CA trust, and have the same access to the same secret, etc., etc. So it's basically it just becomes now like the PKI concern, not as CSI concern. Just something that we document and say, make sure you set this up, and the contract between us and the backup software is this CA trust and this secret.
Is it not possible to piggyback on the Kubernetes RBAC system? And Kubernetes
absolutely, yeah. That's kind of like the second approach we thought of. We delegate it, right? To, of course, like the API server first of all has to trust us. Now he's total all the way down, right? Like how do we, and it's like that, what aggregated API server can do is in the API service resource, Ben, you probably know this, and a few of you are familiar with this, right? You declare you put a CA trust in there, and that's how this API server trusts you. And after that, we just say, hey, every time I got a request, you just delegate the authentication and authorization to API server and say, can I trust this person or this request coming from this source? And then the API server will say yeah or nay. And then of course now we're getting very, very close to okay, are we heading down the aggregated API server path, which is not a bad thing. It just means we're gonna have to tap into using the aggregated API server packages and how to set it up, etc.
I mean, I like piggybacking on the RBAC systems that already exist because it'll simplify deployment of this thing, right?
Mm-hmm.
Less stuff to lay down, and the configuration will be familiar to people who've dealt with Kubernetes before. Just granting another role or granting another action to a role and then binding it to a account. Everyone understands that. And then, and best of all, I think the authentication is known to be secure, right? Like if we invent our own authorization scheme, even if it's like MTLS, with standardized, TLS stuff, you still have to convince yourself that no one can get the secrets and no one can, it's just with Kubernetes, it's, that the authorization scheme is secure, and it's just a matter of can we plug into it in a way where you can sort of delegate exactly the permissions you want to the service that needs to do this work, which is going to be the backup service, right? The backup service needs to be able to present something to the sidecar that says I should be able to call these APIs and get these diff-snap results.
If that makes a lot of sense to me, because if the backup server is already a pod, it would have a service account. Then we can trust the API server to tell us that does this service account have the appropriate RBAC permissions to talk to us and etc. Right? So
it doesn't actually have to be a pod. It just needs the service account with the token and everything, and then whatever it is can authenticate and do what it needs doing.
Yep.
It sounds good to me. I mean, basically the backup vendor would have its own security account, service account, and it will have appropriate RBAC to only able to access this different snapshot CR and read from it, right? That's the only thing that it can do that. Then otherwise other component will not able to access this CR at all, right?
Well, there's two things. The CR will have RBAC around it because all CRs have RBAC around them, right? You have to be granted permission to even read the CR at all. So you're getting through one hoop of RBAC just to be able to read the CR. And then we can put up an additional barrier that says, okay, after you have the CR and you get the URL and you open a connection to the service, it's also going to authenticate you and make sure that you have some additional privilege to be able to call that API.
Okay.
And then, I mean, the second one is arguably optional, right? If you just want to use the ability to read the CRD as your gate, then you could just put some cookie in the CRD and say anyone who knows the cookie, I'm going to trust them, and that's good enough. But yeah, it's even better to have a second layer of RBAC on the second HTTP connection, where you have to authenticate as a Kubernetes user, and then somehow I don't know exactly how that works, to be honest. How you would, if you're not the API server, but you're some other, HTTP server, how you would authenticate a Kubernetes client, but presumably there's a way to do it.
Yeah, either we rely on, like, again, falling back on the TLS cert. I think, yeah, like like the TLS cert, like with its like all these like attributes in there, it can serve as some sort of identity. I mean, that's really what like things like the service mesh do, right? They use the TLS cert as a form of identity ticket, and API server would know how to. Anyway, yeah, there's a lot of gory details there.
Yeah.
We don't have
to design everything auto detail in this meeting, because I think we only have a few more minutes left.
Yeah,
but that is the starter that we have so far, and you can see that there's still a lot of questions that we need help to complete. And
so far, while I have everyone on the phone, there's one last design item that I want to quickly get feedback on, if we have maybe 2 more minutes, which is over if there is like multiple driver pods, how do we handle it? So for example, by default, if I deploy EBS CSI driver, it comes with 2 pods. It's not a daemon set, it's just a deployment which defaulted to 2 replicas. So if there are 2 of these sidecar, the DivSnap sidecar, how do we handle it? At this point, we kind of want to lean towards just following what the CSI external resizer driver is doing. I think it has some sort of built-in leader elections that says only one would be the effective and active leader and work on. The rest will stay asleep until the leader died. I'm hoping that's an acceptable approach, versus trying to juggle over okay, who's going to handle which requests and etc.
That is exactly what the rest of the CSI sidecars do.
Great.
They just have a leader election, and it's active passive.
Okay.
Yeah, that makes sense.
Cool.
Yeah, but if you have 2 replicas of the sidecar and a service in front of it, does the service know who is the leader? Because it needs to route the stuff to the leader only.
I'm sorry, I cannot hear you very well. Could you repeat the question louder or something?
All right, is it better?
Yeah.
Slightly. Let's try it again, Jan.
Okay, so if you have 2 replicas of the sidecar and a HTTP service in front of it, how does the service know who is the leader?
Aha.
It needs to send all the requests only to the leader, right? I don't know, maybe there is some Kubernetes magic to do that, but I don't know about it.
I don't think there is, not at the service level. So yeah, there needs to be some quote unquote intelligence, or either we just use the pod DNS. I don't know. I don't want to use a pod DNS, but if there is the only way to deterministically identify the leader, then we might have to fall back to the pod level name resolution.
Okay, just keep it in mind.
Thanks, John. Appreciate it. Okay, cool. I think that's all I have.
Yeah, so the update is that we have a meeting on every Thursday morning at 8 a.m. Pacific time. So if you want to participate in this project, please, you can send me a message on Slack, or I think email me, and then I will invite you into that conversation that we have. And currently, the split of the work will be as following. I will work on enhancing the CRD according to what we just discussed, and also enhance the deep snap controller. And Ivan, Prasad, and Sean were working on the different source snapshot service with all the security hook and all that stuff that we just present to you. Please, if you have an expert in this area that we are just mentioned, just you can go ahead and jump in and help us. That's all I think I have for today. And thank you, Ivan. Thank you.
So you guys will be working on a POC, right, based on this discussion?
I think we need to discuss a little bit more to secure to have a solid design, and then we will create a prototype. But we're running the work a little bit in parallel. Like my part can be done without a solid design because I can just enhance the CRD, I mean controller a little bit, right? But on the main part is on the Ivan, Prasad, and Sean to redesign that service. Redesign that service.
Yeah, we can break up the tasks into smaller chunks, like during our engineering sync up, and go over it there. But otherwise, I think at this point I am confident that we have a clear path forward. I think some parts might be harder than the others, like delegating to API server, etc., etc. So, but yeah, I do think we have a clear path forward.
Okay. Another thing is just small thing. Right now, I think it's fine because this is what you are using for the POC. But when you formally submit a CAP, please make this generic, in all your diagrams.
Yep, got it.
Yes, that makes sense.
Okay. And thank you. Yeah, for anyone and everyone else who are working on this CBT. Yeah, you guys have made really great progress. So, so we're still trying to do an alpha, right? We can still try to do that. This
we have enough time to do alpha for 1.25.
I mean, the coding is one. The main thing is the CAP deadline. That one is coming, right? So that's the one that that's the hard part.
Yeah, I think we need to.
We can. Oh, but we can actually since this is complete auto tree, we can also say, hey, we don't really have to follow all of those. We just we just continue. We can still continue working on this. Yeah, we can do that too. We can, initially we can just try to follow those deadlines, but if we can't get it done, then we can just have it just tracked out the trip, like what Cozy has been doing.
Okay, maybe I will consult with you offline on how to proceed with 1.25 with this on 1.25. Yeah.
Okay. Yeah. All right. I think yeah, we just have 1 minute left. Anyone has anything else you want to talk about? Otherwise, that's it for today. Thanks, everyone. Bye.
Thanks, everybody.
Thanks, folks.
Great work. Thanks, everyone.
Bye.
Bye.
Yeah.